Okay, so hello everyone and welcome back to my maths homework. This time I'm going to show you these questions with one or two different methods. Okay, so the first question we are going to do using what we call the formulative method. Okay, where we assume that Tn is an expression of a specific kind, and yes, and we assume that it always follows the series which we are given. Fine. So the first series is 3, 5, 9, 15, 23. We have to sum them up to n terms. Alright. So T1, wait, what happened? Okay. So, fine. T1 is, why? Size is all 100. Okay. So T1, that is 3. T2 is 5. T3 is 9. Alright. And then T4 is 15 and stuff. Okay, it keeps on going like that. So the thing to observe is that T2 minus T1, that is equal to T3 minus T2, that is 4, and T4 minus T3 is 15 minus 9, which is 6. So these are in fact in an AP. That's nice. Similarly, you will have T5 minus T4, that is equal to 8, right? 23 minus 15. So here we use the general assumption that Tn is given by a quadratic expression in n. So an square plus bn plus c. Alright. So with this assumption, let's find the values of a, b and c, and let's see if this quadratic expression always works and satisfies the series. Alright. So you will have T1, which is a plus b plus c, is also equal to 3 because that's given. Okay, T2 is equal to 4a plus 2b plus c, that is equal to 5. T3 is equals to 9a plus, wait, 9a plus 3b plus c, and it is equal to 9. Okay. Alright, so now let's subtract this first equation from these two. So that will give me 3a plus b is equals to 2, and 8a plus 2b is equals to 9 minus 3 is 6, which also gives me 4a plus b is equal to 3. Okay, now let's subtract this equation from that equation. So that will give me a equals to 1. Very nice. Which means that b equals to minus 1, and that means that c has to be equal to 3. Alright, so this Tn, this turns out to be n squared minus n plus 3. Okay, so first of all, let's see if this thing actually works. I mean, do we get all of these Tn's for this expression? So you will have T1 is equals to 1 minus 1 plus 3, obviously 3. T2, that's supposed to be 4 minus 2 is 2 plus 3 is 5. Similarly, T3 equals to 9. T4, let's check it out. So you get 16 minus 4, um, which is just 12 plus 3 is 15. Okay, T5, 25 minus 5 is 20 plus 3 is 23. So this always works, no problem. Alright. So what can we do with that now? So now we just need to sum this up, sum this Tn from n equals to, I think we should be summing Tr, right? Sum Tr from r equals to 1 to n. Alright, but this Tr is the same thing as saying summation from r equals to 1 to n of, just replace this n by r, so you get r squared minus r plus 3. Okay, so now we can use our formulas for summation of r squares and n squares and n integers and stuff. Okay, fine. So for r squared, we will have n into n plus 1 into 2n plus 1 upon 6 minus, for r you will have n into n plus 1 upon 2 plus 3. Alright, plus 3n. Okay, let's take an n common from it. I think I should take n by 6 common from it. Okay, so you will have n plus 1 into 2n plus 1, which is 2n squared plus 3n plus 1. Then you have this n is gone, so just got minus n plus 1. But that thing times 3, so minus 3n minus 3. Plus you want a 6 in the denominator, so that has to be 18 over here. This n is gone, so plus 18. All right. And what is that supposed to be? That is supposed to be n by 6 of 2n squared plus 3n minus 3n, that cancels. You got 1 minus 3 is minus 2 plus 18 is plus 16. That's supposed to be n into n squared plus 8 upon 3. I don't know, something like that. Let's see if this works. So for n equals to 1, you will have 1 into 1 plus 8 is 9 upon 3 is 3. That does work. For n equals to 2, you will have 2 into what's this thing, 4 plus 8 is 12. 12 upon 3 is 4. So 4 into 2 is 8, which is correct. 3 plus 5 is 8. So yes, this does work. Alright. So let's move on to the next question with the same method basically. Okay, 1 plus 3 plus 7 plus 13. So what's the difference? The difference is 2, 4, 6, 8, and keeps on going like that. So yes, our general assumption that Tn equals to an square plus bn plus c. Alright, and then you have 1, which is t of 1, that is a plus b plus c. And then 3 is equal to what was I doing? Yes, 3 is equals to 4a plus 2b plus c, and 7 is equals to 9a plus 3b plus c. So that gives me 2 equals to 3a plus b, and 6 equals to 8a plus 2b. Well, that gives me 3 equals to 4a plus b. So once again, a equals to 1. That's nice. B equals to minus 1, just like the before. Okay, and what about c? So 1 minus 1 is 0, and then c equals to 1. Fine, c equals to 1 as well. So this thing Tn, it turns out to be um, n squared minus n plus 1. Alright, let's erase everything away. So yes, now just sum this up. So summation of tr from r equals to 1 to n. That's the same thing as saying summation of from r equals to 1 of n, okay, 1 to n of r squared minus r plus 1. Alright, so for r squared you will have n into n plus 1 into 2n plus 1 upon 6 minus of n into n plus 1 upon 2 plus n. Alright, which is n by 6 of, you got 2n squared plus 3n plus 1. Then you got minus n plus 1, but 3 times of that, so you got minus 3n. Wait, why is this so much similar than like before? Okay, minus 3n minus 3, and you got this. Okay, so you want to have a 6 in the denominator, so that will give me 6 in the numerator, so that will be plus 6, just like that. So this cancels. You got 1 minus 3 is minus 2, so this is supposed to be equal to n by 6 into 2n squared plus 4, which is n by 3 of n squared plus 2. That's nice. Let's move on to the next question. So the next question is 1 plus 3 plus 6 plus 10 plus 15, some stuff like that. So 1 plus 3, okay, so you got 1 and you got 3, the difference is 2, then the difference is 3, then the difference is 4, 5, keeps going like that. Just have to do it in a similar way, sorry. But this time I think I will show you a new method. Alright, so what can we do? We have that the sum till n terms, I should say, that is equal to 1 plus 3 plus 6 plus 10. What's the general term? It's supposed to be 1 plus wait, it just keeps on going like that, so it's not a nice thing. Okay, fine, so it keeps on going like that till you have tn, I should say tn minus 1 plus tn, because that makes more sense. Okay, and then you also have Sn is equals to, just going to leave a spot over there and I'm going to start with this 1 plus 3 plus 6 all the way till tn minus 2 plus tn minus 1. What's this thing? Plus tn minus 1. Fine. And now I'm going to subtract this away, so you get 0 is equals to 1. Just leave it over there. For 3 minus 1 you will have 2, then plus 4 plus yes, so 10 minus 6 was plus 4, then you have plus 6 plus 8, keep on going there till you have tn minus 1, I think. Yes, So yeah, that should be correct. Mm-hmm. Wait a second. Yes, so this has to be tn minus 1 plus tn. Tn minus 1 plus tn. Alright. This is paired up with this thing, okay? Tn and tn minus 1. So all the way till tn minus 1. So how many terms? Just leave this first term like that. So how many terms are what's happening? So how many terms are there in this bracket? There are n terms, right? I mean, consider this thing as one separate term, alright. And then you have minus tn. So that gives me tn equals to 1 plus sum of n terms of this series, this arithmetic series. That is to be n by 2 into 2 times a, which is 4, plus n minus 1 into d, which is 2 as well. So that gives me 1 plus n by 2 of 2n, what's this, 2n plus 2, alright. I mean n by 2 of these things. So 1 plus, you got n plus 1 into n, that has to be n squared plus n. So yes, tn equals to, yeah, n squared plus n plus 1. Let's check it out. So if you put, wait, what? This cannot be. uh I don't know what's going on. So tn is equals to this thing, looks correct. Wait a second, is there really n terms or n minus 1 terms? I mean, you start with 2, 4, 6, 8. All right, so 3 minus 1 and then 6 minus, oh yes, so these are n terms, okay, and then these pairs, there are n minus 1 of them, so these are actually n minus 1 terms, right? And that's why this was not working. So just replace this n with n minus 1. All right, so it's the same thing, n into n plus 1, but now uh yes, n into n plus 1, but now instead of having n, you will have n minus 1. So n minus 1 into n minus 1 plus 1, that's just n. So n squared minus n plus 1. So if you put n equals to 1, you do get 1. If you put n equals to 2, you get 4 minus 2, which is 2 plus 1, which is 3. Then you get 6, then you get 10, stuff like that. Okay, so that's our uh, general term of this sequence, n squared minus n plus 1. Nice. So there you go, two methods explained. Now just sum this up from 1 to n. Alright, so this is our tn. Yes. So if we sum tr from r equals to 1 to n, that is the same thing as summing up from r equals to 1 to n, r squared minus r plus 1. And yeah, what's that supposed to be equal to? So you got r squared n into n plus 1 into 2n plus 1 upon 6 minus n into n plus 1 upon 2 plus n. So you got n of these ones, so plus n. Now let's take n by 6 common, so that will give me n by 6. You got I mean 2n squared plus 3n plus 1. Then you got minus, you have 3, right? So minus 3n minus 3. Then you have 6, so plus 6. All right, so this cancels. You got, yes, you got minus 3 plus 1 is minus 2, so it's supposed to be equal to n by 6 of 2n squared. What's it supposed to be? Plus 4, which is n by 3 of n squared plus 2. Why is that so similar? Fine, so yeah, some y, so okay, fine, this is similar. Oh wait, sorry, so we just did this question once again, that's the problem. All right, I mean, when you put n equals to 3 in this, you get 9 minus 3 plus 1, which is supposed to be equal to 7. So it's not this series that we summed, it is this series that we summed. But anyway, you get the idea that how do we do this with the other method. Fine. So now just need to do this thing first, right? Because we just did the previous question repeatedly. Alright, so now we want to do this thing, and I think with the same method. Alright, so you got 4 here is supposed to be equal to 3, 2, 3, 4, 5. I think it's going to be simpler because you just have 2, 3, 4, 5, stuff like that. Fine. So what are we given? We are given that s is equals to, I mean sn basically, 1 plus 3 plus 6 all the way till tn, which can also be written as a blank spot plus 1 plus 3, keeps on going like that till you have tn minus 1 plus tn. Alright, now let's subtract this. You get 0 equals to 1 plus some series which is 2 plus 3 plus 4, keeps on going till you have actually this time I'm just going to include that 1 as well, till you have tn minus 1. Alright, plus tn, I mean sorry, minus tn, sorry, I just got a cold. Okay, so that gives me tn equals to 1 plus 2 plus 3 4 till what, n terms, right? Because over here you got n terms and for each of them you have pairs. For this one you just have 0, then you have 1, then you have 3. For this tn you have tn minus 1, so there are n pairs, right? So there are going to be n terms in this sequence. So yeah, that's just basically the sum of first n natural numbers, which is n into n plus 1 upon 2. That's it. That is our tn. Easy, very easy. Just check if this works. So yeah, it's working. So you got, yeah, that was very easy. This was very obvious as well. I mean 1 plus 2 plus 3 plus 4, that's 10, and then 1 plus 2 plus 3 plus 4 plus 5, that's 15. So yes, this is very obvious. So just sum this up from r equals to 1 to n of r into r plus 1 upon 2. And if you, yeah, if you have actually seen my previous videos, you would be knowing that this is actually equal to r into r plus 1 into r plus 2 upon what's this thing, this is 2 factorial, you will have 3 factorial, which is 6, right? Just check it out. So if you put, I mean it's n into n plus 1 into n plus 2 upon 6. So if you put the value of n as 1, you get 1 into 1 plus 1 is 2 into 3, which is 1. So that's correct. If you put the value of n as 1, I mean n as 2, you will get 2 into 3 into 5 upon 6. That's supposed to be 5. Wait, what? No, you will get 2 into 3 to 4 upon 6, which is 4. So yes, 1 plus 3 is also 4. Then you put n equals to 2, so you get 2 3. No wait, we just put that. So put n equals to 3, so you will get 3 into 4 into 5, which is supposed to be 12 into 5 upon 6. So this is supposed to be equal to 2. You got 10 basically. So yes, 1 plus 3 plus 6, that is in fact 10. So yeah, this is completely working. All right, so the next thing is what's this thing, 4 plus 6 plus 9 plus 13 plus 18, keeps on going like that. So once again we are going to go with our general assumption stuff. So you got 2 3 4 5 stuff. So just use the assumption that tn equals to an square plus bn plus c. Alright, so what does that give me? That gives me that the first term 4 equals to a plus b plus c. Then you have 6 equals to 4a plus 2b plus c. Then you have 9 is equals to 9a plus 3b plus c. Subtracting the first two, that gives me 2 equals to 3a plus b. Then subtracting the, I mean this equation from that equation and dividing that thing by 2. Wait, no, just don't divide this by 2 because that won't be nice. So you'll get 5 equals to, wait a second, sorry, 5 equals to 8. Is this correct? Yes, that looks correct. So you got 8a plus 2b, right? So let's multiply this thing by 2, so that will give me 4 equals to 6a plus 2b. Now subtract these two, so that will give me 1 equals to 2a, or a equals to half. Fine. And that gives me 4 equals to half of 6 is 3 plus 2b. So this has to be like 1, so that gives me b equals to half as well. Okay, now let's put this in this equation to get 4 equals to half plus half is just 1 plus c, so c has to be equal to 3. So this tn actually turns out to be n squared by 2 plus n by 2 plus 3. Yeah, I don't know why, but it does turn out to be that thing. Wait a second. Yeah, it has to be turning out to be like it. You just see that 1 plus 3 is 4, then 3 plus 3 is 6, then 6 plus 3 is 9. So it's just the previous series but with an additional 3 in every term. So yeah, it has to be 3 plus the formula which we got from the previous one, which was n into n plus 1 upon 2. Alright, that's easy. Now if you want to sum n terms of this thing, uh, I'm not going to do the the complete thing. Just do the previous one. I mean, what we did for fifth, and then subtract 3n from that thing, just like that. So our s is going to be n into n plus 1 into what, n plus 2 upon 6, but minus 3n basically, right? Yeah, I mean plus 3n, sorry, so yes, plus 3n. So that will be equal to n, and by 6 I should say. You got n squared plus 3n plus 2, then you got plus 18, right? So n by 6 of n squared plus 3n plus 20, right? That's nice. Let's move on to the next question. So the next question is 2 5. Oh god, why is this cold happening to me? Okay, so you got 2 5 10 17 26, keeps on going with that. So the difference is 3, then the difference is 6, then the difference is 7. Sorry, difference is 5. What did I do? So the difference is 5, then the difference is 7, then the difference is of 9, keeps on like that. So yes, just 3 5 7 9 stuff. Yeah, um you know what, this could be much better. Yeah, so I'm just going to put this 2 as 1 plus 1. Okay, so if there was a t0 term, it would be 1, then you have a 1, and then this would be 2, then you have 3 5, stuff like that. So I can already say that for n equals to 1, we just have 1 plus n squared. For n equals to 2 also, you just have 1 plus n squared. For n equals to 3, you just have 1 plus n squared. So our general term is supposed to be 1 plus n squared, right? And this is coming from the fact that 1 plus 3 plus 5 all the way till n terms, that's supposed to be equal to n squared, right? The sum of the first n odd numbers, that is n squared. Nice thing to remember. So yes, that's our tn. So now if we sum this from r equals to 1 to n of 1 plus r squared, that's supposed to be equal to n plus n into n plus 1 into 2n plus 1 upon 6, and that's supposed to be equal to n by 6 of 1 plus, I mean 6 plus 2n squared plus 3n plus 1. That's supposed to be equal to n by 6 of 2n squared plus 3n plus 7. Alright, so that was nice. Let's move on to the next question. Why is this happening? Okay, so you got 3 plus 7 plus 14 plus 24. So what's the difference? You got 4, you got 7, you got 10. Yeah, it's also an arithmetic progression. Yeah, so you can do this if you want to. I'm not really wanting to do this, but fine, just do it. So tn equals to n squared plus bn plus c. So what do we get? 3 equals to a plus b plus c. 7 equals to 4a plus 2b plus c. And 14 equals to 9a plus 3b plus c. That gives me 5. No, wait, 4. 4 is equals to 3a plus b. Okay, and then you got 11 equals to 8a plus 2b. Multiply this thing, so you will get 8 equals to 6a plus 2b. Now subtract this thing from that, so you get 3 equals to 2a. So a equals to 3 by 2. Now just put it into this equation, so that will give me 8 equals to, you got 3 by 2 of 6, that's supposed to be equal to 3 into 3, which is 9 plus 2b. So that gives me b equals to negative half. B equals to negative half, a equals to 3 by 2. Put it in this equation, so you get 3 equals to 3 by 2 minus half, that's just 1. Okay, plus c, so c equals to 2. Alright, so there you go. Don't need anything else. B equals to negative half, a equals to 3 by 2, and c equals to 2. So our tn turns out to be a, which is 3 by 2, n squared, then you got negative half n plus 2, right? Sorry. So now just sum this up from r equals to 1 to n, right? So our sum, and that's supposed to be equal to, you will have 3 by 2 n into n plus 1 into n plus 1 upon 6. You can see this cancels, you got 4. Then you got minus half of n is supposed to be equal to n into n plus 1 upon 4. Then you got plus 2n, obviously. This is supposed to be 4 as well. So first of all, just take common these things. We got n into n plus 1 upon 4 common. Then you got 2n plus 1 minus 1, it has to be 2n. So yes, just get 2 over there, so it's supposed to be equal to n squared. And I mean there's plus 2n as well, so yeah, just got n by 2 common. So n into n plus 1 is n squared plus n. Then you got plus, you got that 2, so 4, right? Plus 4, so there you go, n by 2 of n squared plus n plus 4, like that. So that was easy. Let's move to the next question, which is 1 plus 4 plus 3 plus 40. Oh, okay. So here you got the difference of 3, then you got a difference of 9, then you got a difference of 27. Oh, then you got a difference of 81. So these are actually powers of 3. Alright. Now the general assumption for these kind of sequence is that Tn is equals to a times r to the n minus 1 plus Pn plus c. But it's a hard thing to remember. And what about this one? It's just 2 3 4. No, it's not nice. So yeah, this thing is actually very hard to remember, and I don't think I would be remembering this unless I've just read it from somewhere, right? Just revise it. So it's very hard to remember. That's why I'm going to present another method which is easier and much more sensible than this one. So that method says that you have t2 minus t1 equal to 3. Then you have t3 minus t2 equal to 9. Then you have t4 minus what, t3 equal to, you got 27. Keep on going like that till you eventually have tn minus tn minus 1. So now you can see what's happening. For 1 you have 3 power 1, for 2 you have 3 power 2, then you have 3 power 3. For tn minus 1, that's supposed to be 3 to the power of n minus 1. Now just add them all. That will give me tn minus t1, right? When you add this thing up, all of these, just get tn minus t1 equals to 3 to the first power plus 3 to the second power all the way till 3 to the n minus 1 power. All right, that's supposed to be 3 times, how many terms are there? N minus 1 terms. So 3 to the n minus 1, yes, minus 1 upon 2, right? Because 3 minus 1 is 2. So there you go. Tn equals to, what's t1? T1 was 1. So 1 plus 3 into 3 to the n minus 1 minus 1 upon 2. Alright. And now we can sum this up. It's basically the same as the method which I showed you for the previous questions. I mean the second method which I showed you for the previous questions. Just this time you have a GP instead of an AP. Alright. This is called the method of difference, Okay, fine. So yeah, what do we do with that? Now just sum this up. So we have, first of all, just simplify it. So you get Tn equals to 2 plus 3 to the n minus 3 upon 2. That's supposed to be 3 to the n minus 1 upon 2. So the summation of tr from r equals to 1 to n, that has to be equal to the summation from r equals to 1 to n of 3 to the r minus 1 upon 2. Alright. So this can be written as half summation from r equals to 1 to n of 3 to the r minus 1. So half, what's the summation of 3 to the r from r equals to 1 to n? That has to be 3 plus 3 square plus stuff like that till 3 to the n power. So 3 plus 3 square till 3 to the n. There are n terms, obviously. Then you got 3 to the, and then 3 to the n minus 1 upon 3 minus 1, which is 2. So yes, it's supposed to be 3 by 2 of 3 to the n minus 1. Then you got minus 1, which is just minus n. So yeah, that's it. That's the solution. Fine, let's move on to the next question. So the next question is 2 plus 4 plus 7. Oh yeah, just take the difference. You got 2, you got 3, 4. Yeah, very nice. You got 5, something like that. Just going to write this 2 as 1 plus 1. So you got a 1 as our t0 term, and you got 1 over there, right? So now it's very obvious to see that t1 equals to 1 plus 1, obvious. Then t2 equals to 1 plus 1 plus 2. t3 equals to 1 plus 1 plus 2 plus 3. Keeps going like that. So you just have tr equals to 1 plus r into r plus 1 upon 2, like that, which is also equal to r squared plus r plus 2 plus r, no wait, yes, so it's going to be 2, right, upon 2, right. So if we sum this up from r equals to 1 to n, what's that supposed to be? Yeah, I'm not going to go into all detail of doing this, and we don't even need this thing. Just got this thing, tr equals to 1 plus, right, it's like 1 plus, actually I should put tn. So tn equals to 1 plus 2 plus 3 all the way till n. Yeah, so now if we sum this up, you get Sn, right, equals to how many ones have you got for this line? Yes, obviously n of them. Then over here, this sequence is the same as saying n into n plus 1 into 2 into n plus 2 upon 6. Just memorize this if you want to. So that's supposed to be equal to n into, actually n by 6 into 6 plus n squared plus 3n plus 2, just to equal to n by 6 of n squared plus 3n plus 8, right, just like that. So yeah, that was the last question and we are done with my homework. Hope you enjoyed. Wait, what?